Okay, today we are going to make a compiler. First, we're going to start with the tokenizer, and then we're just going to be parsing function signatures. So let's get started. We'll make a folder called front end. And we just wait. My machine is ancient. It's from like 2014, so it's 10 years old. Okay, and then do tokenizer.odin. Also make a main.odin. Okay. Package. Front end. We'll make our main function. Let's just import the basics. Hello. Let's just make sure this works. Args. Contents, comma. os dot read entire file. Args. This one. Two. Okay. See what we need to just parse this function. Valid identifier colon int funct arrow. And I think that's all the token kinds that we need for this function. So let's create the token struct. In a kind, which is a token kind, and start and end, and we'll just make those use 32. So each source file can only be 4 gigabytes large. So we'll just do that. If the lane of the contents is greater than the max of the U32, we'll just panic for now. We cannot make source files larger than 4 gigabytes. Okay, and then I guess we'll hold our parsing state in a struct called tokenizer. Okay, future me here. I forgot to explain what a tokenizer is, and I realized that might be valuable. So if we have a little bit of code here, we want to take the strings and then put them into substrings and give them a type so that it's easier to understand what we're doing. So we would just like take boxes over these things. So this would be a token. In our compiler, each colon is a token, but you can have it as like 2 colons as 1 token if you want. The function, keyword, oops, the parentheses, the x, this, the int keyword, this parenthesis, the arrow, and then lastly the int. So each of these would be given a type. So strings that are alpha start with a alpha character, an alphabetic character. That isn't a keyword. We would call those identifiers. Just make this smaller. And then these are just colons. This is a funct keyword. And this is also an identifier, colon, int keyword, arrow, I guess. It's just to give more structure, so you have a array of like more meaningful data rather than just like an array of characters. And what we're gonna do with this is we're gonna be parsing. So when we hit the square identifier, we're gonna check the next token. Okay, that's a colon. If it's another colon, we know it's a constant declaration. Okay, we're at this colon. Okay. We don't know what the language is going to look like, but if it's like Odin or Jai, if there's another keyword here, okay, we know we're parsing a function signature, and we should almost always expect that the next token is going to be a left parenthesis. And then we can have a more generic thing that parses the fields in here. So yeah, this is a list of parameters. So you would have each parameter could be like a struct. So we could have a field struct, and all it would have is a name and a type. And then we do that, and we can have a structure. We can parse this data more easily into like a coherent structure, and so in our function data structure, we'll have like a name. We'll have parameters, and we'll have like a return type. So we're in a state machine. Okay, we know we're parsing a function, so we parse the parameters. That goes in here. If there isn't an arrow, then it's a void function. But if there is an arrow, we'll expect a return type right here. And then we can put the return type into here. And this is just to give us more structure so that it's easier to lower like to another language or to an intermediate representation. And yeah, we'll cover what all of those things are, but this is why we tokenize. And that will have tokens, which is a dynamic array of tokens. Thinking, I guess we'll have a current and a previous, which are U32s. I think that's all we need for now. So Just gonna close, save. And we'll make our tokenize function. Pointer to a tokenizer. I guess we can put in the file name and the source, which is, we'll just have that as a wow, I'm blanking on the name. A slice of bytes, and we're not gonna do UTF-8. We're just gonna do ASCII for now, but it should be easy in the future to go further than that. So I guess we should make a tokenizer init function, which takes it's a proc that takes in a pointer to a tokenizer. And then I guess that's all we'll do for now. I'm just gonna do t dot we'll do the file name, which is a string, and then the source, which is a slice of bytes. So then we'll do t dot file name equals file name, t dot source equals source, and then the tokens is equal to t dot tokens make dynamic token, which just creates a dynamic array of tokens. And then that's all we'll do. And then I guess we'll have to have a core.mem pretty sure we can just ignore the result. Okay. How do we want to do this? For t.cur is less than the length of the source, it's a U32, so we have to do that. We'll create a new file called token map. And all this will have in it is a map that takes a string and outputs a token. And then func equals dot func int equals dot int, and I think that's all the keywords that we have. Colon. Yeah, we'll just do the single and 2 characters manually. We won't use the hash map for that. Okay. And then we'll do the character is equal to t dot source dash t dot cur. And we'll also have t dot prev equals t dot cur. Then we'll switch on the character, and if that is a alpha character, we'll have a function like a tokenize identifier. How did I spell it? Identifier. Or keyword. Which takes in our tokenizer. Case, if it's a colon, produce colon token. Oh, and also put new line in there. My hands are so cold. Okay, so it was very cold, so I got gloves, I got a sweater on, I got a new pair of socks, gloves, and some agua. So let's get back to it. Don't think I can type with gloves. Whew. So we got the new line. We got a couple of errors. Case. New line. And what else do we got to do? I guess we'll create a helper procedure called append we'll just call it append token. Cold hands do not type well. And this will just take a start, end, and a kind. All this will do is append to the tokens, a token where and kind equals. So it does nothing, but it's okay. It'll save us a little bit of typing. So at the end, I guess we'll just cur plus or t dot curve plus equals 1, and we'll just t dot curve. And so we're producing Is this correct? I'm not sure. You know what? We gotta add before, and then it'll be correct. So we're just gonna copy this and then change this to new line. And yeah, we'll create this procedure. Okay, and then we'll do for or code dot is number. Oh. T dot cur plus equals 1. And then we'll go kind comma okay equals tmap. Oh. That's why. T dot source, T dot prev to T dot current. And then we'll do if okay, append token. You know what? This is kind of redundant, so we don't need this. T dot prev T dot cur. And we'll just do dot the kind return, otherwise we return Otherwise, it's an identifier. So we have to go back here and just fix this. Okay. We also need, if it's a minus, okay, now we got the arrow shit producing tokens. Let's see. What do we do now? I guess we can test it out. So we'll go tokenize, or first we'll create a tokenizer. And then we'll do tokenizer init. And then we'll print the tokens. So create a fn prototype dot, yeah, square func x int and we'll do for testing purposes we'll just keep it to one file. Simple slash fn prototype dot cot. Let's see what it do. Oh yeah, we forgot to tokenize. That's not good. Let's see what it's doing. File name, source. We got 0 tokens. CHs. S, okay. And then, so we should go into this function. It's not what I wanted to do. Did we get a token, though? We did get a token. Cool. Oh, shit, we forgot white space. Yeah, so we get here. And then, yeah, nothing happens. Okay. So, I'll do a white space case. And t.cur plus equals 1. And I'll exit out of there and I'll go up. Let's see if this works. Okay, so we're still, shit's still broken. What's happening now? So let's see, we have, we have 4 tokens. That means okay, we get here. Oh, yeah, we didn't do parentheses. Left parent. Left. Please work. Okay, 29. I'm not sure how it is, but if it's let's see if this fixes it. Okay, now we're gonna have to go see what's up. Bump, 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 bump. Function, right paren, x colon space int right paren arrow space int. Okay, so let's just make sure this goes well. 1, 2, 3, and then we should break. Ooh. There's probably a more elegant solution to this, but I'm just going to bound check on that that loop. So this is so we'll fix this up later. And t dot cur is less than the length of t dot source. Yeah, and we have to convert it to a U32. Okay, now do we work? Bruh. Maybe if I put it in front, so that it's like the first condition that's checked. Hey, okay. So what we should expect is identifier, who cares? Colon, funct, uh, r paren, sorry, left identifier, colon, int, right arrow, int. Let's see if that's what we got. Okay, identifier, colon, func. So far, so good. Left paren, identifier, colon, int. Then we should have right, int, right, arrow, and then int. Okay, we are good. I guess we can move on to parsing. That was pretty quick. Let's see what time we're at. We're at 40 minutes and we, damn. Okay, so that was pretty quick. Maybe I'll edit it down to like the key important parts, but impressive. So I guess we can, we'll make two files. One will be AST, and then the other will be parser. And then I guess we got to add the package. And then now we got to think about how we want to represent the structure of our AST. So I guess we'll have like a node called function decal. Yeah, that's what we'll go with for now. And I guess we'll have like a file node as well that just represents, has a list of declarations that are all in our file. Strict. And then, yeah, that'll have a we'll leave that blank for now. Right now we're only focusing on this, so it'll have a name. What should we do? I think everything should have a name, so maybe we'll make a base node. That has a token index, and if every AST is specific to a file, there should be less nodes. There should be less tokens than there are characters, so I think it's safe to assume. Yeah, no, it definitely is safe to assume. I think like the heuristic is like every 5 characters is a token. So, I think we can just go like that. And that way we can save some space rather than using like a reference or having the token inside completely. And then you can just do some polymorphism here. Forget using node. I think that's how you do it. And then we'll have a this has our function name. And then we can do field list. And then I'm going to pause and think about this for a second. Okay, so this is what I come up with. It's a stupid UML-like type diagram, but it's what we're going to do. So let's get to it. So we'll just comment this out. We have a token index. Okay. Using node. Oh. And then You know what? For now, we'll not deal with types, and we'll just do everything as an int. So we'll just have a params array of node to do make type system. We don't need this. We just need this. So we'll go to parser. And we'll create a parser struct to hold our state. And in here we'll put a tokens, which is a list of tokens. And we'll we got the tokens. Current node we are processing. And do we need anything else? We'll just start with this and we'll add things if we need it. So we'll do parser from tokenizer. That'll just take in parse. Okay, so I guess big thinking going on. So we're expecting a colon. And this is going to be a big if tree, but whatever. Else error here probably, or maybe, well, who knows? So we're expecting a colon, and then we're gonna expect another colon. Okay, p dot cur plus equals 1. I think the design will come later. We're definitely going to have to clean this up quite a bit. So we're going forward. Expect p dot cur. And then we'll do okay, so if it's a colon, we know it's a declaration. So I think we should just get rid of this in one. And so it's an identifier. We go up one. We're expecting a colon, so we'll go here. Yeah, that's what we'll do. And then, colon. So we got the first colon. This is the second colon telling us it is a constant declaration for now, just a function. To do add all constant and other decals. So, okay, we can increase P. And a parser needs an AST, so we'll do this. And then we got to go to AST, create any node, which is a union of node function decal. And yeah, we probably want to return any node. And I think we want shared now. Okay. Oh yeah. Oh. Ugh. We're at an hour. Okay, so we got this. We're at the colon. And, okay, token. Yeah, this is not how we want to do this. Hold on, I'll just, yeah. Okay, I took a big break and also did some coding off camera. So we should have a parser right now, but it's definitely broken and it definitely does not work. So yeah. Any node, and then parse, we'll just return any node, and then we parse decal, this returns any node, so we'll just return this right now. To do add all decals to file. Add all decals to file node. And then we'll just return nil to make the compiler happy. And let's see if this works. It certainly won't, but we'll try anyway. Let's go to main. So one thing I did is I added a virtual memory arena to allocate all of our AST nodes. I guess I should increase the font size so you guys can see. Yeah, we just initialize an arena and parse, and then we parse it. So we should t.print line node nil. Oh shit. Oh shit, did it work? Okay, we got a function declaration and its node is its token index is 0, and it has these parameters: a field node at token 5, type nil, and the return type is nil. And I haven't implemented a type system yet, and that's why it's doing nil. I did that on purpose because you don't want to get too ahead of yourself. But holy shit! Oh my god! That's crazy. I was not expecting that to work the first time. Wow. Okay, I guess I'll do a little overview. So, yeah, we have any node. So if like if a AS2 node has a connection to any node, if it only has, it'll use this type. If it has a connection to any declaration, it'll have this type. If it has a node, yeah, this is the node, it's just a token index. This is stupid. I think we can get rid of that. Yeah, field is just a token and a type, and I haven't implemented the types yet. Now we have a function declaration which takes a list of these fields, a main token, and a return. So I think we can take our function and just parse it to C, and we'll just assume that when the type is nil, it's just of type int. And holy shit, I was not expecting that to work the first time. That was the first time I ran it. I'm genuinely so excited. Wow. I was not expecting that to work. Because I probably did like an hour of coding. And I didn't test it once, but geez Louise, it worked the first time. So excited. So just for the sake of doing things quickly, we'll add a C backend in the front end, but we'll change it later. We'll separate it. To C code, and then we'll just there's a procedure that'll take in any node. Also take in a string builder. We'll call that B. And then we'll switch on the node. Yeah, it's just like this. What's the error it's giving me? Function decl is not an expression but a type. In this context it's ambiguous, but switch, what should it be called? Type, kind, n, r, node and node. I'll just do n and node. I think this is it's a point. Like if we do that, will it? Strings dot builder string. We need something. Oh, there we go. Okay. You know what we need to do? We need to add the source to the parser. Okay. Yeah, we need to add the parser to this. You know what? If I get rid of this, I can just go using tokenizer. Ooh. No, we'll do it the way it was before, and I'll just we'll just add the file name like a bozo. Just do some copying. Then we got to go to there we go. P dot source equals T dot source. P dot file name equals T dot file name. We should be good to go. And then we'll maybe in here we'll go get node name. Proc that takes in P, which is a parser, and a node, which I guess it's just a node, and I assume everything's gonna. I don't think everything has to have a. Whatever, it doesn't matter. And then this will return a string, and we'll just go return string p.source dash node. Okay. We'll get the token. And then there we go. There's some cleaning up to do, but it should be fine for now. And then we'll do strings dot write string b . Oh yeah, and this needs to take in a parser as well. And then I guess we got a strings dot write rune b . Keep it symmetrical. And then for field, comma, index in fin.params. So it'll go if field dot type equals nil, because we're saying that nil is we're saying that nil is an int type because we don't have a type system right now. So we write the type. And then then we write the name. And then if index equals lane fn dot primes -1, we can actually just go right byte. We can change that there too. It's probably a little bit quicker. Okay, let's see if this works. We need to make a string builder. Core strings. Yeah, I think that's all we need. But it probably also returns an allocation error, so we'll do that. Then we'll put in B there. Does that work? Okay. And then we'll do strings dot toString code. And we put in B. And then we'll just print that out. Let's see if that works. Okay, I think we're going to need to go into the debugger. Front end, C back end. Oh shit, we're dumb. Ooh, we forgot. Forgot white space. We forgot white space. I guess. We'll fix it up later, but this is how we're doing it for now. Right byte. Okay. Int. And then we go space. And if it's not equal to the last parameter. And then Well, I guess we want this here too. And then we probably also want it here. Yo, look at that. We got all the shit we wanted to do today. That feels good, man. I did do a lot off screen, so next one, when we think what we'll do next is we'll try to get like primitive types in there so you can get like floating point stuff and all that shit. And yeah, wow, we got it parsing from our from this into this. That is beautiful. That's cool. I don't know what else can we do. We got that, and then we got to do precedence parsing. I guess we'll add to the plan. So yeah, we did all of that. I guess tomorrow we'll try to do this and see if we can get that working. And we're also going to need our piler to know when new lines are useless or know when they're useful. So we're going to have to put at specific points in the compiler when we want to ignore new lines and when we want them, because this is much easier to parse because you can just ignore new lines altogether, but I think it's much nicer to just have no semicolons. Add body and statements and basic expressions, no precedence. To our compiler, add basic type system for primitives. And yeah, I don't know what else we need to do. I guess that's what we'll do for tomorrow. Yeah, I mean, if you liked watching, subscribe. I plan to do this once a week, but this weekend I'll probably do it multiple times. But yeah, wow, first try. I guess I'll put the code up on GitHub so you can look at it. And yeah, peace.